Hi class, my name is Mr. Michael, the physics teacher from ID Minds Foundation School. Our topic today is gravitational field. But before we go into definition of what a gravitational field is, I would like us to look at the meaning of force. What is force? A force is that which changes a body state of rest or uniform motion. In your book 1, you were taught that force is classified into two. Force is classified into two, which are what? The contact force and the what? The field force. The two classes of force are the contact force and the what? The field force. It's a contact force. A contact force is a force whose source requires a contact with the body in which it is what? Acted upon. Examples of contact force are push, pull, tension force, and friction. So these are the examples of contact force. These are called contact forces. Why? Because their source requires contact between the body in which they do what? They act. The second class of force, or the second classification of force, is the what? The field force. What is a field force? A field force is the force whose source do not what? Require a contact with the body in which it does what? Act upon. Examples of field force are what? The gravitational force, magnetic force, and the what? Electric force. So these are the three examples of what? Field forces. So these are called field forces. Why? Because they do not need any form of contact for them to do what? Exist. Now, looking at this example, you discover that our topic today, which is what? The gravitational field, is a perfect example of what? A force field. Now, let us define gravitational field. But before we define what a gravitational field is, I would like us to look at the meaning of what? Field. What is field? A field is a region or space under the influence of physical agencies such as what? Gravitation, magnetism, and what? Electricity. Now we have different types of field, which are what? The electric field, the magnetic field, and the what? The gravitational field. Having known the meaning of what field is, now we are set to define a gravitational field. What is gravitational field? A gravitational field is a region or space around a mass where the gravitational influence of that particular mass is what? Experienced. Every known substance which has a mass on the Earth's surface actually exerts a measurable amount of gravitational force on other what? Objects. What is a gravitational force? Gravitational force. A gravitational force is a force which tends to pull all bodies towards the center of the what? Earth. Just as the law of gravity states that anything which goes up does what? Surely comes down. That is according to the law of what? Gravity. For an object to feel the effect of gravitational force, that object must possess what? Mass. The object must possess mass, which is a function of its what? Weight. What is weight? Weight is the gravitational attraction which the Earth does what? Imposes on the body. If an object is massless, definitely that object may feel a gravitational force which is what? Negligible. What do I mean by negligible? Insignificant. Every single mass on the Earth's surface actually exerts a measurable amount of gravitational force on all other objects around it, as we've said before. For instance, the Earth the Earth and the Moon. The Earth and the Moon are about 3.85 times 10 raised to the power 5 kilometers apart. Now, if you look at this distance, you discover that it's a very, very far or long distance. But even at that, the Earth still exerts a measurable amount of gravitational force on the what? The Moon. So, the Earth is able to exert a gravitational force on the Moon. Why? Because of the gravitational field that exists around the what? The Earth. For every single mass on the Earth's surface, around every single mass on the Earth's surface, there exists a gravitational field around that particular what? Mass. So with the help of this field, that particular mass can attract all other objects or all other masses without what? Contact. That is why we said earlier that a gravitational field is an example of what? A force field. The gravitational force, let's say F, between two masses, M1 and M2, separated by a distance R, is proposed by a scientist known as Sir Isaac Newton. From this, Newton proposed his famous theory, which is known today as Newton's law of universal gravitation. Newton's law of universal gravitation. What does this law state? Newton's law of universal gravitation states that every particle on the Earth's surface exerts a force on every other particle, and this force is directly proportional to the product of their masses and inversely proportional to the square of the distance separating them. Now, let us interpret this law mathematically. Newton's first expression states that F is directly proportional to M1, M2, which is a direct proportion or a direct variation. The second statement of Newton, he says that F is inversely proportional to 1 over what? R squared. Now, this is a direct variation and this is an inverse variation. Now, combining both variations, we have a joint variation which is given as F directly proportional M1, M2 all over what? R squared. Now, this is just a mere expression. We change it to an equation by introducing what? The proportionality constant, which gives us F equal to K M1 M2 all over what? R squared. Now, this is the mathematical statement of what? Newton's law of universal gravitation. Let's call this equation 1. Now, in physics, every constant has its own meaning. This constant of proportionality in Newton's law of universal gravitation represents a term which we refer as universal gravitational constant. Universal gravitational constant, which is given symbolically as capital letter what? G. Now, if you substitute G into equation 1, we have F equal to G M1 M2 all over what? R squared. Equation 2. Equation 2 is the mathematical statement of Newton's law of universal what? Gravitation. F means what? The gravitational force. M1 and M2 are the masses of the two bodies. R means what? The distance separating the what? The two bodies. Then in physics, some constants have a numerical value which we can use to represent them. The numerical value of G equals G equal to 6.67 times 10 raised to the power minus 11 Newton meter square per kilogram squared. So this is the numerical value of the universal gravitational constant. Having known the mathematical statement of Newton's law of universal gravitation, I think we have to solve one or two examples to better our understanding on how we can use the equation to solve problems. Example: two masses, 4 kilograms and 5 kilograms, are separated by a distance of 30 centimeters. Full stop. Compute the gravitational force. Compute the gravitational force between the two masses. In bracket, take G equal to 6.67 times 10 raised to the power minus 11 Newton meter square per kilogram squared. So the question says two masses, 4 kilogram and 5 kilogram, are separated by a distance of 30 meters. Full stop. Compute the gravitational force between the two masses. Take G equal to 6.67 times 10 raised to the power minus 11 Newton meter square per what? Kilogram squared. Before we start solving any question in physics, the first thing we have to do is to do what? To bring out our parameters. Bringing out the parameters will definitely give us a hint on the particular formula to use in solving that problem. Solution. Let M1 equal to 4 kilogram and M2 equal to what? 5 kilogram. Our R, which is the distance, is equal to 30 centimeter. Now, if you look at the mass, if you look at the two masses, they are in their respective SI units, which is what? Kilogram. But if you look at the distance, which is R, each unit is given in what? Centimeter. Centimeter is not the SI unit of distance, but what? Meter. So we have to convert from centimeter to what? Meter. Converting from centimeter to meter, we do what? We divide by 100. This is equal to 30 all over 100. This will give us 0.3 meter. And our gravitational constant is given, which is G equal to 6.67 times 10 raised to the power minus 11 Newton meter square per kilogram square. Now, looking at the parameters given, mass, R, and G. Of course, we know that the relationship, the formula relating all these parameters is the Newton's law of universal gravitation, which says that F is equal to G M1 M2 all over what? R squared. Now, let's substitute the values. We have F equal to 6.67 times 10 raised to the power minus 11 multiplied by 5 times 4 all over 0.3 squared. This is equal to F equal to 6.67 times 2 times 10 raised to the power minus 11 plus 1 all over 0.09. Now, if you punch your calculator, as I'm going to do, 6.67 times 10 raised to the power minus 11 plus 1 multiplied by 2 all over 0.09. This is equal to 1.48 times 10 raised to the power minus 8. Therefore, the gravitational force F between the two masses is equal to 1.48 times 10 raised to the power minus 8 Newton. Our final answer. I hope you actually understood this. See you next class. Thank you.